we do not exactly know the amount of reinforcement in our beams, columns, etc., then we shall use this type of value. If it is a slab, around 1%, if it is a beam, around 2%, if it is a column, around 2.5%, and inputting 0.8%. So this is for preliminary or approximate estimate. Okay, we will assume that these reinforcements are there in different members, and then we will do our calculation. What is the total reinforcement required? And then that is to be multiplied by the rate, and we shall get the ultimate cost of the reinforcements in our structure. Then this is another rough estimate that if it is a residential building, around 4.5 to 4.75 kgs of steel will be required per square feet of construction, and this is for commercial building. Now this is because the residential building will have lesser loads, you know that already. Commercial buildings will have higher load, therefore the residential building has less requirement of reinforcement, and commercial building has higher requirement of residential building. Again, this is for a preliminary estimate. We do not exactly know how much reinforcements are going to be required in our structure. Then this is a formula that we should remember. This formula is used for finding out what is the weight reinforcement per running meter. Okay, in kg, so kg per meter. Now, if I want to find out what is the per running meter for a 16 mm diameter bar, for example, I will put 16 square divided by 162, whatever is the value, that is kg per meter for a 16 mm diameter reinforcement bar. And one reinforcement bar, okay, that is available in the market is generally going to be 12 meter long or 40 feet long. So I will multiply it by the length to get the weight of 1 unit of reinforcement. Okay, so that way I can calculate what is the unit of what is the total weight of this much numbers of reinforcement bars, or vice versa, whatever I need. Okay, so this formula we shall remember, and these values also we shall remember. Okay, then for every quintal of steel reinforcement, around 0.9 to 1.3 kg binding wires are required. What are binding wires? Those are those coils that are used to bind the reinforcement in their place. Okay, the reinforcement, the stirrups, we bind it with a coil, right? That is binding wire. So it's very simple. For 1 quintal, around this value, around 1 kg, okay? 0.9 to 1.3, so around 1 kg is required. Then we already know these brick sizes, right? This is known to us. What is the nominal brick size? What is traditional brick size? This is known to us. Then if we are adding mortar on these brick sizes, obviously if we are doing brick wall, then we have to use mortar, right? Now, after applying mortar, what is the size? This is the size after applying mortar. So if we are going to find out number of bricks required for a certain amount of work, say for example 1 cubic meter of brick work, we want to find out what is the bricks required. Then which value we shall be using? We shall be using this value, right? Because in that brick work we have to apply mortar also. We're not using only the bricks. So if we use this value 19 centimeter by 10 centimeter by 9 centimeter, then it will be wrong. We have to use 20 centimeter by 10 centimeter by 10 centimeter value, and then we may also have to add a little bit of extra bricks because there will be some wastage, there will be some breakage and in the side. Okay, and if we are asked that use traditional bricks, or we are using traditional bricks, then this is the size of the traditional bricks, and after using mortar, this will be the size of those traditional bricks. Okay, and then using that value, we will have to find out how much bricks are required in that volume of brickwork. Now we have a question here. We are asked to do the rate analysis for RCC work at slab. The percentage of reinforcement is given to us. The ratio of concrete is given to us. This is M20, where we are asked to carry out rate analysis by taking 10 cubic meters of work, and then we have to find the rate for cubic meter. Okay. Now this ratio, we did the calculation for PCC also. The initial calculation is exactly same. What is the dry ingredients required? Dry ingredients required, we have to multiply with 1.57. What is this 1.57? This is a shrinkage factor, because when we will mix the fine aggregate and coarse aggregate and water and cement, they will shrink. There are voids in between fine aggregate around 30%. There are voids in between coarse aggregates around 25%. So this makes up around increase of 55 to 57% increase is required, and therefore we are multiplying it 1.57, and we are finding out this much dry materials, total dry materials will be required to produce 10 cubic meters of concrete. Then we have this ratio. Okay, I'll put double equal sign. We have this ratio 1 divided by 1 plus 1.5 plus 3, that we understand. One part is cement, and we are finding out the cubic meters of cement. Then we also understood this value in the last class. So we are dividing with this value, and we are finding out how many bags of cement will be required. These are exactly same, I guess, as the PCC calculation. So again, 1.5 part is fine aggregate and 3 part is coarse aggregate, and we are finding out what is the volume of fine aggregate and coarse aggregate. Then when we go to the calculation, materials, we have 82 bags. Per bag, this much is value, and this is the cost. For sand aggregates, coarse, this is the value, and this is the total value. For stone aggregate, we are using 20 mm. Okay. And these are the values, and these values are being taken from schedule of rate. I told you in the last class also that schedule of rates will be different for different places, it will be different in different states, but for our purpose, we will be using one model schedule of rates. From there, we'll be taking our values, because we just have to learn. Anyway, these schedule of rates are changing along with time, so there is no point of following one particular schedule of rates, right? This is changing all the time, and we have to update ourselves according to that. We have to know what is going on in the market, what is new schedule of rates, and if there is some values to be added or increased, because at certain times what will happen, the department will say that whatever the values are given in the schedule of rates, the rates to be used in the project are to be increased by 2% or 3%, whatever, according to the prevailing market conditions. Then steel. Now steel is said that it is 1% of our work. What is our work? 10. Now do not use 15.7 here. Okay. Our concreting work ultimately was about 10 cubic meters. So 1% of 10 cubic meter is much cubic meters of steel will be required. Now what is this? This is the density of steel, 78.5 quintals per cubic meter. So we are using that density, and we are getting that we should be using 7.85 quintals of steel, right? Then this is the rate we are considering, and then ultimately this value we are getting. Then binding wires, because we are using around 7.85 quintals, so binding wires also will be required. Just multiply it by 1 and little bit more. 8 kgs of binding wires will be required. This is the rate taken from schedule of rates, and this is the total cost. So we got this total value. Now, mason in the PCC work for 10 cubic meters will require 2 masons. Now, because this is RCC work, more work will be involved in RCC, obviously. Therefore, we require 3 masons. And head masons now also requirement is more. You need half or we need one mason to look after 20 cubic meters of work. Okay, then Mazdoors is almost same. We will require coolies, we will require VST to do the water works. This is lump sum. If we need any tools, now we will require, because we are dealing with steel bars, we will require blacksmith. Okay, whatever is the amount of reinforcement works, say we are doing around 7.85 quintals of work, around that much. Okay, for 1 quintal we need one person. Around that, then we will require blacksmith, we will require the number of Mazdoors, then this is lump sum. So finally we get this total value. After adding, then we add all the costs of materials and labors and we get this ultimate value. Then we add these two. Okay, we are adding 1.5% water charges, because if we are using the water from municipality services, the municipality will be charging us some money. If not, obviously this is free, but we are considering it, considering we are using water from provided by the municipalities. And then we get this for water charges and the profit to the contractor. It is not mentioned in the question, but we will be assuming around this value if it is not mentioned in the question. And this is our profit to the contractor. So this is our grand total. This grand total was done for 10 cubic meters. So divided by 10 is this value. This is for per cubic meter of work. Okay. Then this one I have shared with you. So this is a model schedule of rates that we shall be using. Here we have different types of Mazdoors and laborers. Okay. Blacksmith, first class, second class, carpenter, coolie, whatever. So that we will be using as per our requirement. Then here we have materials. Okay. Berries, bamboos, stone, shingles, stone that are available in the river. Okay, the rates will be different for rivers and then broken ones. Okay, this is broken stone, so the rates are different. So we shall be using as per our requirement, and there are different sizes. Okay, if we are doing RCC work, generally we are here like 20 mm size. So fine sand, coarse sand, if we are using it for concreting work, then generally we will be using coarse sand. Okay. So this way we have different types of rates. Then here we have reinforcement. Okay, so this is for TMT bars. This is for super tactile TMT bars. Okay. Then this is for mild steel bars. This is for binding wires. This cement is given as metric ton. We do that, what we have to do for metric ton, we have to convert it into weights, right? Whatever cubic meter we are getting, we will multiply by 40 kg per meter cube. That is the density of cement. We will get it in weight. We'll convert it to metric ton, and then we will use this weight. If we are not provided rates of cement per weight, then we have to do it in metric tons. So that we will be doing.